Resume recording, yeah. Hey, it's Coffee Compiler Club. We're here to talk about compilers and road trips across the country and garbage collection and type systems and language runtimes and anything and everything to do with compilers. You're being recorded. You'll show up live on YouTube within a couple hours. That's it. I don't have any set agenda. I usually start these things with a 30-second AA update, and then we pivot to whatever anyone wants to talk about. And my AA update is that my latest round of theory hacking is going well, and all my tests are slowly lining up in a row with a new improved version of what nil means in a typing system. After that, I voted and done house things, and I have more house things to go do because my Sunnyvale house has an offer on it. And I'm closing soon, which is good because I took a stupid hard money loan to get the new mansion. I'm in a fucking mansion, it's fine. And I got to get rid of the hard money loan, so I have to sell Sunnyvale. So I have been doing a lot of realtor things and loan things, and that's still going on and will go on for another couple of weeks. But then maybe I'll be done and moved into a new house, and really enjoying it here, man. So that's my status update. Cameron threw me a fun link on ABCD. I threw it in the docs. Let me throw up the docs. Well, I need to throw it up here for this. It's basically it's a cheap, easy range check elimination test that I looked at after I had done hotspots range check elimination. It's like a nice sweet spot in that it's easier to do than what I did, but gets fewer loops, but it's sort of relatively obvious how it works. And one of the key things it has is an SSA minus in it, which I would claim is like not exciting because it's all the effort to build SSA, but you only get half the benefit. But they need less than full SSA to go do the range check tests they're doing. That was the summary. He threw it out to me last night. I assumed he was going to be here and talk about it. He's not here yet. Whatever. So does anyone else want to talk about anything, or you want to dive into range check elimination and or algorithms like this? No one's read the papers. I just threw it out on the link. So
I was a little curious about tooling to help people with software that changes over time.
You mean like
if I want to detect that I have made a backward incompatible breaking change?
Well, you have to have a test that tests compatibility.
But there's some things you could detect automatically. So like if I have a function where I add an additional optional argument, I haven't broken the world because you can just not give that optional argument.
Right. Well, you have to decide your semantics say I'm allowed to add extra. I mean,
if I add an additional non-optional argument, I've broken anyone who wants to try and call me because I've required something extra.
Sure. So you're
but most compilers don't have access to what did the old version of this look like.
Right. So that's a pre and post condition kind of thing. You're doing Eiffel, and you do in fact get the compiler have a documentation of what things were, and you can see that you've changed it.
So that was my sort of question. How do people have opinions on how you should build that tooling? Should I have some artifact of the build that says, here's a bunch of facts about the state of things at the time I did the last compile, and then feed that into the next compile? Or look at the old version of the code and essentially compile everything twice so that I can diff the old one against the new one?
I generally treat compatibility at a higher level. So the artifact as a whole, so your Java and you're doing, I still implement the Java spec. Then I have a spec compliance test, and the new version passes the compliance test. That's all the promises I ever made anyhow. So I'm compatible and it's done. The fact that new things are allowed that weren't allowed before is not part of the question. I don't detect it, and I don't fail you out.
Well, that would depend on where the new stuff is. If it's in an interface that people are expected to implement, then if your new stuff aren't default methods, then they have a problem.
Right. So that's the TCK, JCK tests, and that
Right.
would be a breaking change by the test.
So
So
I
And
see
it's
a lot
not-
of Java projects, like probably via Reflection or Java P or something.
Yeah.
Can look at the interface of a build, and they keep an artifact that kind of captures that summary, and they can compare one versus another, and
the-
then
the-
probably you can
certainly-
detect which ones are affect the API of what you're offering, and decide what's compatible and not.
So there were certainly breaking changes in the JVM over the years that were outside the spec. So at one time, Reflection returned things at the order that you got out of a hash table. And when the hash table implementation changed or the hash function changed, the order changed. And various folks who iterated over via Reflection, the members of some particular whatever, then failed because they were expecting them in one order and they were getting them in a different order. But the order was never a guaranteed part of the spec. So the behavior changed, but the spec was still met. Now, is this something you want to flag, detect, declare an error? The spec is bug for bug compatible. Like, where do you draw the line?
Well, I'm not in the camp that says that that was something that you should have depended upon. And
Okay.
it reminds me of the sort of the story of Make and doing things in parallel. Make ought to do things in random orders all the time, even if you say do it serially.
Yeah.
Do them in some random order, and then you won't. You'll find out soon enough if you had an implicit dependency somewhere.
I totally agree with you, but that's because people rely on these orders. And then I can get there's another more fine-grained thing, which is like time. I optimized your program. It now ran faster. You were depending on the slowness in order to make something happen, usually because you had a race, but because things were slow, the race didn't bite you. Now something's faster, A beats B, but you had a dependency on B being before A, except that you didn't make it explicit, you're now broken. Okay.
Yeah, well, you might have that even without a compiler, even without a recompile. You're running on a different machine where not all
Yeah.
CPUs are the same, and
Right. Well, you just got a new machine and the machines are faster or slower or whatever. And suddenly it broke. And this, Java went through this for years and people finally began to accept that, hey, this multi-threaded out order thing requires some thinking about order dependencies and blah, blah, blah. And all I'm saying is, if you're interested in capturing changes in behavior, it can come from a lot of places and they can hit a lot of things that, you kind of like squirrel your brain out a little bit and say, wait a second. What is my spec here? And so Aaron was like, hey, I have a calling convention change. I accept more things. Is that a breaking change or not? What's a breaking change to you?
Yeah, and so I think Aaron's questions can be much more general. We're not just talking about, Java. It can be the particular, library that Aaron's building and wanting to be sure that he doesn't break things for his clients, right?
There's this famous paper about, doing broken things wrongly or something, doing the right thing wrongly. And it was, in the end, it was a 30 or 40% performance hit because the student's name was different than the professor's name. And the act of changing the UUID, your username, changed the environment variable layout, which caused the stack to transition across a page boundary. And you endlessly took page fault misses in the TLB. So it was all TLB faults. And this in turn on a particular rev of an x86 caused the iCache to not prefetch across the cache line boundary where the code landed. And that was worth this giant performance hit. And the ultimate result was, you have the wrong name. So yeah, right. So this is like, okay, is this a breaking change? I got 50% slower because my name's different. What the fuck?
Well, some of the ideal, like Thrift and protocol buffers, I believe protocol buffers, but for Thrift, they will ignore a new field. There, it's enough to have the fields, and if you add new fields, and it's all.
Yeah, very specifically by design, they're saying we're going to allow future changes, and we're going to track backwards compatibility by saying you meet all the old fields, but you can have more.
Yeah, that's a means of change of evolution.
Yeah, okay.
Right. So with Thrift, I have seen tooling that says if you mark this thrift as persisted and it's going to get written out somewhere. and you do something like remove something from an enum so that all of the enums shift by 1, it will give you an error and say, you can't delete an enum. This is a persistent thing. All you can do is rename the one you were going to delete to deprecate it.
Okay, so
And
that gets into,
that was a pre-commit hook that compared what had been committed to what had not been committed and said,
Yeah.
I'm not going to let you commit this thing because you said at persisted.
right, so you have a persistent data structure. Oh, you're actually checking the code that generates the persistent, because
I suppose I should say a durable infrastructure.
Well, that depends
Basically
on
test
on the encoding of that enum, right?
Yeah, I heard that
If
part
using
too.
just the implementation numbers, then maybe that's a bad idea. It doesn't allow for the kind of evolution that might happen.
So I heard, right. I heard
Yes, if we had
things.
dictionary encoded it, where I spit out, okay, here is the mapping from numbers to strings, and then use the numbers inside the data encoding,
Right.
we would not have had this problem.
Well, you have a different problem, which is this enum is no longer supported. And that's what happens when you come across a serialized form you're reading back in that has that enum. Right, so you don't have a backwards compatibility plan. Previously written serialized things, persistent things no longer are usable in the new system because the enum doesn't have a mapping. And now you get into, how the hell do we provide backwards compatibility? Somewhere you have to have a reader that reads old version and updates it to new version. And when an enum comes along in old version, it knows semantically what to do to make new version.
Yeah, and my specific question is, where should tooling to help you deal with that live? Should that be part of the language? Should that just be some tool that exists independent from the language?
I'm of the opinion that you got an artifact which is testable, and that's a disk thing, so it's not in the compiler. And I can be talked out of my position for sure.
Yeah, I don't think you can expect all of this in the compiler or in the language. You're going to need help from in your code base to make sure that you're playing by your rules, right? So it might be perfectly acceptable to change the members, reorganize, renumber, add, removes of one enum, but not of other ones, because the first one's internal. Nobody gets to look at that one. It doesn't show up in a persisted artifact, but the other one does. And so you have different rules.
Yeah.
So
I mean,
if
I
you
went down
want
this path with the fintech looking for fraud for 7 years after we declared something was fraudulent or not. We had to have evidence that we could present to a court of how we made the decision. So we had to read our old spec file in whatever format it was and do something semantic, but the new system rolled forward and kept doing new things, had new tests, and it had new AIs and new models and whatever. So you had to present what the compliance officer saw at the time, 5 years ago.
To me, there is one more dimension where we talk about source compatibility, but we have to include backwards binary compatibility, of course, too. So the tooling for sure can help for source compatibility, but what about binary compatibility?
So the generated artifact you make, you're talking about like DLL hell here?
Yeah, it's some there can be in backward incompatible binary changes. Yeah, the two can help you for source compatibility changes, like Aaron said, for missing arguments, which field, more fields to an interface, and
that's what I wanted to say about this thing. So when I'm working on a project that's rolling forward and has history, I rarely want to have the current code have the entire history of what it used to do in my face all the time. So you asked where tooling goes to handle history. For me, it was pushed off to the side as this is how I handle backwards compatible things. So once I reached the point where I had to think about it and deal with it, there was a version number on loading that was checked. It went through the version number upgrading process to bring you up to the new version of things. The new code had no memory of how the old code used to work because I didn't want to have it in my face. And that memory was only kept in the version upgrade path. which would read the old stuff and do the necessary, hey, you use the enum I deleted, and what is the semantic meaning of that?
Yeah, but thinking the other side too, what Sarah said, I believe it's beneficial to at least the compiler to say to you not how the code was changed, but will it still work with the current changes, which I believe is kind of a different.
Wait, will it still work? What is it still
So
work?
it still work for here will be a source compatible.
So if it compiles, that's obvious.
Yeah.
But now will it run?
Will
And
it
that's
run
testing. And
with
that's what
your
I'm saying.
older code? Will it run the same with your older code, or it will break? Which is
So I kind of don't have hope that an automated tool will tell me this still works.
Yeah.
I'm just looking for an automated tool that tells me you did one of these 16 things that will make it break that I can detect.
Yeah, and I claim
Even if you give me some of the failures, if you can give them to me more quickly, then I deployed this to prod, and then it got mad at me because the database had some old object in it that it couldn't deal with.
I claim testing.
Yeah, and one more facet would be it's not uncommon in a large system that there are some older versions. There are some mix with the versions of the program compiled. You have a old software that still works somewhere in the system. It's not uncommon to have different versions in your large code base, if you will.
Yeah, it can be difficult to get everyone in the world to update at the same time.
Yeah, that's what I'm trying to say.
That's one of the ways in which H2O is a little bit cleaner than, say, a distributed hash table. With H2O, you can be like, we are all on the same version.
Yes.
I restarted all the servers on the new version.
Yes.
But if you've got a bunch of stuff that's just out there in the world controlled by different people and someone's running hash table software from 5 years ago, like,
yeah.
To your question where this tool should live, I think Go has like a quite interesting middle way. So they have this like massive Go tool, which is the compiler in itself, but it also is the unique testing framework, and I don't know what else. So you basically always call Go, and you can also give additional aliases as commands and configure it. So it could be an internal or an external tool, but you basically have like one command line. It always looks like you call something on Go.
But what is it testing?
So the standard library has a standard unit testing framework. So you can use the standard library to define your unit tests, and Go test will just run that. They basically put everything what is possible into the standard library. That's what it feels like.
Okay, but there was a test.
Right.
And you failed the test or you passed the test. And all I'm saying is, to answer to Aaron's question, it's a test. And if you have a case where you have some version of whatever you're updating and there's some object in the database that you don't now happen to hit or won't deal with rightly, that should be caught by a test.
But you could also argue that there's a tool checking for source compatibility against the previous Git commit or whatever, right? Which would be check compatibility.
But so what is check compatibility checking for? That's what I'm coming around to. What's it do for Go for compatibility? What's it mean to be compatible?
The 16 things he mentioned that break the compatibility, whatever that is.
Yeah, so you had to list those. That's a test.
Right.
And the bad thing, you can have a variation of these and you're back into the multiple mixing checks, and there's no.
Well, there's a separate things of how do you upgrade a system rolling lazily where you have multiple competing spec standards and you're trying to do an upgrade. Yeah. That was, non-blocking hash table will update table sizes recursively any number of times simultaneously, but that was carefully well engineered into the design of the thing.
And that's pretty common. A lot of companies very much want to do I'm going to roll out 1% of the servers to the new thing, and then 5, and then 25, and then 50, and then all.
Right.
Like, you better have the old thing and the new thing capable of operating side by side.
And then it becomes a matter of how you wire them in your system.
Yeah, there's a versioning spec thing between them all that they can negotiate and agree on what it means to update.
That is really nice because it's a middle ground, but with a system that it's proven to work, and a new system that can afford some
right.
instability.
So are there tools you
Engineering
want in the
is-
standard library to make that more obvious how you would accomplish it?
By means
So
of
the thing that you have to deal with is that A's talk to A's just fine, and B's talk to B's just fine. But also B's have to talk to A's in A's language just fine. And so when you're making the B, you have to make sure it can talk to an A in a way that A can understand.
Yeah.
So always B has more trouble. And then once everyone's on a B, you can drop the A's, then you can drop the B talks to A translation step. But you can't drop that until first everyone's on a B. And that means you do a lot of engineering just for the transition. I kind of went round and round on this in H2O again because of the consistency model in the early days when we were doing weak nodes. You can have a fail out and pick somebody up, and it's this classic problem of split brain or cluster coherency and shit like that. How do people who come and go understand what the cluster is as a whole? And that can get you into, Paxos models and coherency models of various kinds. Basically, you're writing a large coherent cluster that has a mix of A's and B's, and the B's all talk fine with the A's and all with each other, but how the B's talk is not related to necessarily how the A's talk. And the only way that translation works is if there's some semantic bridge going on from how the A's talk to how the B's talk, that B understands. A doesn't understand the semantic bridge, but B has to.
that. Go ahead.
So the way we solved that at Hazelcast, at least in the past when I was still there, is when you had different versions in the cluster behaved like the older version for everything until everything was updated and you manually said, okay, switch to B now.
Okay. So you
and up to that point, you basically had a communication going on.
right.
Did that become a testing nightmare that you had
It
the
did,
new
it
version
did.
in production for 3 months
Oh,
and then suddenly the
yeah.
last of the old thing goes away and your bug surfaces?
And that was the reason why we only said we support like build revisions and one minor version, because everything else was a freaking nightmare. I mean, the build matrix was like, I don't know how big anyways.
We certainly at H2O went through the stage of trying to make it reliably upgrade, but we just semantically, we threw things in a state machine that was semantically understood by everybody, and the state machine itself wasn't updating, but the communication protocols around it. So we at least had a semantic base we could all agree on. And then,
So what were the hard parts of that and what were the tedious parts of that?
The hard part was getting the coherency protocol understood by everybody. And that we never got an upgrade path per se going. And then we pivoted to being machine learning and didn't care anymore. So we first got everyone to understand that values existed and individual nodes were a home to a value and you had replicas. And then when a node dropped, you changed homes and the replicas had to get passed around and shit like this was going on. And at the same time, the actual protocol that we used to do bit transfer between nodes was wanting to be modified as well. And we kept the notion of, hey, this is how I understand who's the home and who has the value, who's the key guy, who knows what it means, and who's just a copy. But we never got the actual protocol rolling. Wasn't worth it. We knew we could do it and it wasn't worth it to engineer it. And so we just rebooted the cluster. Similar to what Chris was saying, you were on the old version to you're on the new version. And then we pivoted away from it. So I don't know. I think the problem can be solved, but I actually didn't solve it in a production setting. I solved it in an academic setting.
So that was one major benefit for keeping everything on the previous version in terms of communication. If the cluster update failed, you could always say, no worries, go back to the old version and you restart everything in the previous version again, because the cluster was still consistent. That was
Yeah,
the
so
that.
so when we pivoted, we bailed away from keeping the persistent cluster. And that solved it the cheaty way. We just rebooted to the new version and then the versioning check.
I mean, if you can atomically update the world, then that's nice.
Which is what we did. Yeah, chemically updated the world. Yeah. Once you're on the same version of the cluster communication, we certainly allowed you to, but that's not fair. We allowed you to add code, which was part of the math models that are going to get executed. But that code was, the cluster did persistence on code it was going to get executed for running the math models. Did coherency and correctness on that. So everyone ran the same code that was injected after the cluster was up and stable. But that was the cluster itself was guaranteeing we were all using the same model of code. Like if you were doing a particular version of running a k-means algorithm, for instance, and you wanted to run a new version of k-means, the old k-means ran and the new k-means ran, but those two never shared code. And we all knew that you had two different versions and they were only ever talking to each other.
Was there a REPL in H2O where I could tweak my algorithm, run it, tweak my algorithm, run it?
On H2O? Yeah, for the R, you spoke R, or you did Python, you had a REPL. And again, everyone just hand shook on what it was you were running. Sorry, I had a bunch of people just, fine, that's fine. A bunch of people talking to coffee club at me that, well, let me look one more time. I told them I took them off the invite list because they no-showed for like 3 months. And then
I don't know
they're
anyone
like,
who ever.
hey, I
did
want to be
that.
back on the mailing list. And I'm trying to say, do I need somebody to do an invite right now?
Who would ever just like go away for long periods of time and then just randomly show up again for a few minutes? And
Right. Who would have a life, right?
I just saying.
I was making fun of myself mostly because I just
I heard you. But it's a problem I have, right? So over the years, and Coffee Club's been running several years, I have several hundred folks, most of which no show all the time. So should I just infinitely grow the list and send you an invite and you'll never show? And my list consists of 500 people, of which 20 show in a fairly regular basis, or filter it. And so what I do is after you've done long enough, I hand you I'm throwing you off the list. And then you can come back and I also say, yeah, if you want back on the list, just ask.
So wait, are you saying that death detection is difficult in a distributed system?
Exactly. It is. Are you actually dead or are you just hiding? And
I don't feel so bad that I've missed a couple lately.
Oh, no. And then the other one, of course, is that I have all the numbers of how long people have been coming. And if you're a regular for many years, it'll be a long time before I hand you a death notice. I'll let you run on for a long time under the assumption, hey, you're on vacation, you're moving to a new house and your life is higgledy-piggledy and up in a mess and you'll get around to it when you can. Yeah, fine. So yeah, I would love to have said I actually solved this problem, but I didn't. I cheated on it. I was working on it. I thought I had a good academic solution. And then the market was like, hey, Hazelcast exists. Why the hell are we fighting them? All right, let's go do something else. You weren't the only reason, but there were several such reasons floating around. And we were like, okay, we could do this. We can beat Hazelcast at their own game, but it's not really worth it. Let's just go do this greenfield machine learning thing. And maybe I could have beat Hazelcast at their own game and maybe I couldn't. It never was done, but machine learning. So there you go. And then cluster persistence was not an issue anymore. Instead, it was all about ease of writing the bigger system and writing your complicated math and speed of execution. And that was different stuff. So I like our model that we got for cluster coherency protocols. It was, fast Java model and fast and exact. It was Java and exact, but we tossed out the problem of the cap theorem that says somebody is always lives, whatever. One of the cap arms we threw out. It was a different arm that most people threw out. All right, everyone got quiet.
So, okay, we can bounce back to the LLVM link. Cameron is here.
Oh, yeah. Why'd you throw me the link on ABCD, Cameron?
Oh, I just thought it was somewhere up your alley.
It was. So I talked about it for 5 minutes. I'll talk again before you showed up. So I'll talk again here. It's like, I did range check before ABCD came out, and then it showed up like a year after the range check was running well. And I looked at it and decided it was kind of an interesting sweet spot. Had I known about it before I started, I might have done something different. I might have, looked at what ABC was doing, but I already had a solution which was heavier weight to implement, but it covered more loop cases, covered more special cases. Like I was well handling irreducible loops, and irreducible loops in Java show up every time you have a try finally catch handler inside of a loop, which catches outside the loop and then runs again. So you have a loop and a try finally and a loop. The inner loop throws, catches on the outer loop, and then re-enters on the inner loop. You get an irreducible. And it's a really common pattern for people doing walks over file directory subtrees, and the big directories with lots of things and loops run for thousands, except they throw out of blah, 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 disk read, whatever. So you have to do something about the irreducible loop case. This is like 90 to 95% of your hot loops are not irreducible in Java, and like 5 to 10% are. And that's much higher than you get out of C code. Like C code, people never write irreducible loops unless they're being really stupid. And they throw go-tos in weird places. And the senior developer comes smacks you and say, write this code without the go-to, and the irreducible goes away.
It would be different in C++, wouldn't it?
I don't know. I didn't code C++ with their handler, so I don't know what maybe C++ guys get it now, or STL libraries maybe give you irreducible loops in places. I don't know. But a lot of the C compilers have been around a while, and they just went and handled irreducible loops as the long bug tail of cool optimizations I want to get to that I've never gotten to, and eventually it comes to the top. It came to the top faster for me. So I did it before ABCD came around, and I was like, well, I can't do ABCD because I didn't do irreducible. And I did some other stuff that didn't do well, and I don't remember all the details. Like weird shit, like people will do wraparound math that was correctly being range checked, where they added 4 billion and change to their index, but that would wrap on a small integer, and I could range check that properly with overflows and shit. There's a lot of corner cases that were handled that I don't know, but the irreducible is probably the only one that really mattered. And then the other comment, yes, the other comment came out was this SSA minus form with SSA pi instead of phi or whatever. And I kind of looked at that just yesterday or this morning and was like, this sounds a whole lot like SSA minus, all the work to go build and only half the benefit. And so why would you bother? So I'm kind of the opinion that ABCD as an algorithm on SSA form looks interesting as a price performance trade-off point. It seems to do a good job on common cases and misses some more difficult cases, but maybe you don't care about the more difficult cases, at least not right away. But the pi versus phi is like not interesting. Because if I'm going to go to the effort of SSA, I'm going to get all the benefit out, and then I don't need the pi. But that's me saying I'm always SSA all the time because of all the knock-on benefits. Hey, Matt.
Hey,
So is that the only question there, Cameron? Is it just a comment about ABCD?
Yeah, I was curious if you had intersected with some of those words I didn't recognize.
Yeah. Yeah. I claim if you're doing range check elimination in your JIT, you should look at ABCD and just add it to your list of, oh, this is a cool idea, and maybe this is the right or whatever. And like I said, it was too late for me. And I did a heavier weight, harder engineering problem, and I solved a more general case.
Okay, next topic.
Moving right along. Fine.
So, does somebody has an?
No, we're all just going to be nobodies today. We're going to be homebodies or something.
So I've been mostly coding in Ruby, Kotlin,
You
C,
poor
make
slob.
files, everything
Why?
except
Except
So I'm doing-
ecstasy.
I'm doing homebrew support.
Why are
I
you
don't know.
coding in Ruby?
So homebrew is homebrew formula are written in Ruby.
Oh, geez.
And if you think JavaDoc at its worst was bad, you should see Ruby. Holy fuck.
Java
Anyway.
doc. What
Yeah,
does
like
Ruby have to do with Java doc?
because I don't have like 20 years of memory of Ruby coding, so I actually have to look at the doc.
Are you saying the docs of Ruby docs are bad?
It's hard to find stuff. Yeah.
Okay. I will claim that Java docs, people tried really hard. I mean, this
Yeah,
Tosh
yeah.
block got it started and they,
Up until modules were introduced, JavaDoc was great.
okay, good.
So I don't know if you've seen the changes with modules, but it's pretty hard to follow now.
No, I don't do modules and I'm not looking. And
So what's great about Java modules?
Nothing.
yeah, why do they exist?
Well, it's a good idea. It's just hard to introduce something that fundamentally
Different.
different that late in the game.
I-
But
Still claim they're pretty useless except for anything as other than JVM.
that's what they're for, is for the JVM.
Right, but why make it an open thing then? I still claim it's pretty.
Because it's hard to
eventually
hide.
for anyone else.
But I hear you, Chris. So I mean, if you talk to Mark, he'll point out like the main purpose of the modules was to modularize the JDK itself.
Right,
So
but
if you look at modularizing the JDK as the end goal, it was fairly successful.
Besides modularizing the JDK, it's also making it harder for people to abuse parts of the JDK,
That is
which I
true.
think is a good goal.
Wait, people
don't
abuse the
get down that
JDK?
rabbit hole.
Yeah,
I know it sounds terribly unsafe.
yeah, exactly.
I would never do unsafe things to the JDK.
Running with scissors.
Running with scissors. Thank you very much.
I just remember what was it? The Java conference in St. Petersburg. You don't remember the name right now.
I've been
Peter
to
Lorre and
several.
I did. Peter Lorre, huh?
I've been to several Java conferences in St. Petersburg.
Okay.
Two.
Anyway, Peter Lorre and I actually did a talk specifically called Running with Scissors, where we showed all the creepy things you can do, not only with unsafe, but also with reflection and stuff.
On the JDK?
Oh,
Wow.
yeah.
Well, yeah. Well, reflection, it opens up such a can of worms. That was so, I want to say, so badly done. Fine. It's a final field. Okay, reflect, remove final, change it, reflect, add final. Oh, yeah, it's still a final field. And then now ask your JIT politely, what's it mean to compile a final field? Okay, the answer is, shit, I don't know.
Yeah. We
Okay,
need
so
final, right? Make it a real concept.
Exactly. I'm serious final.
should a language have a reflection?
Well, wait,
Yes.
I am of the opinion, the
Yes.
same opinion as Cameron, is that reflection should let you do everything you could do at the source level directly without a reflection. So if you have a final field and you set the final value, you can't change it in the source. You can't change it in reflection.
Well, I'm tempted to say that reflection is a failure in a type system, but that's
No,
too long.
I'm claiming I would restrict reflection to things I can do in the type system. It's just I didn't actually write that code at the time, but I'm writing it now. But if the type system allows it, it does, and I'm okay. And so there's no failure.
Yeah, Go has a lot of weird quirks, but the reflection system is actually pretty good. It's completely type safe. You can't do shit because everything is typed at runtime.
Tested, typed at runtime? You said typed at runtime.
It's actually typed at runtime, so types are checked at runtime as well. So
During
you
the
can't-
normal
can't
running things,
inject
or when you're,
anything
So
into-
what's the point that type check it's at runtime is basically Python?
yeah, right.
It's basically because you also have pointer types, so you can't inject a random pointer except for you use specifically unsafe pointer. You can't
Okay.
do weird
Ignoring
things.
the unsafe, but using reflection, can I break the type system? No. Okay.
No.
If I'm running without reflection, do I pay the overhead of having types everywhere? Okay.
No.
If I add reflection, is it pay as you go? Because I'm using reflection, you type what I did at runtime, which is what reflection is anyhow. Yes, it's runtime type checking, excuse me. Okay, that I'm totally good with. If I don't use reflection and I don't pay the overheads at runtime, perfect. If I use reflection, I pay that cost, including the type safety checks that come with reflection. And I only do things that are type safe. I think that's cool.
So where are the spots you resort to reflection at runtime? Are there spots that you cannot figure out something at compile time and you have to resort to reflection?
And anytime you have to do anything with JSON.
Yeah, there you go. I was coming up with a REPL where the user is asked to enter an expression.
It's the easiest thing. Any
Yeah.
kind of dynamic JSON stuff.
Okay, the
You're
weak spot
lost.
is converting from strings. Okay,
Yeah.
that's
I'm
acceptable.
deserializing some format into what I expect to be a known, strongly typed internal format to do my shit with. So deserialization wants to type check the shit out of that string.
Okay, that's maybe the only point. Some other point.
Well, similar behaviors like the user is asked to enter an expression that evaluates to how he wants to have some modality set or whatever. And you want to have something that allows you to add dates or do in date checking or whatever. You can either totally restrict it to being just some sort of date like thing, or you can say, and here's an expression that you can write to say before and after this or whatever. And I'll just, evaluate it late, confirm that you give me the correct API about whatever, and then I'll do my type checking, and then I have a well-typed result. And that gives me somewhat more flexibility than just saying you can.
Handling variation this way, I'm not so sure about it.
Okay, fine.
So
It's a val at runtime.
I'm generally have a mixed feelings about reflection, because more I look at maybe not the case, but more I look at, you can go away with reflection with almost.
I agree. I totally agree. You need to see a reflection as one tool in your toolbox. And it should certainly not be the first one. But anything you do with serialization will certainly come back to reflection at some point. Even in direct memory in the past, what we did is we analyzed the types at runtime, the Java types and the structure of the types, and then we generated bytecode with ASM.
Okay.
HTOA did something very similar for talking between nodes in a cluster. They asked, they looked at the structure of whatever the data types you wrote, and we wrote a serializer, deserializer that was custom made, but we did reflection on your structure to decide how to write the serializer. And the serializer did all this cool shit with cluster smarts about compressing the data types, which were often highly compressible and all that kind of crap. It was a custom serializer one-off for your data structure. And that was reflection built.
So generally, go ahead.
I just wanted to say it certainly has use cases.
Yeah. And in our case, we read your data structure types. And then as a separate thing, we emitted code that passed the Java verifier. When that code executed, it would make a clone of a golden instance of your data type, and then run Java bytecodes to set fields and constructors that were final, and it would do all the correct Java things. But there were a few places where we couldn't set fields because of cyclic references. We had to unsafe it to do field sets.
So you said final fields. Didn't you just claim that this is a bad idea? Just like 10 minutes ago?
I made a new object. Right. I'm deserializing. No, it's deserialization. Yeah. So separately, when I was at Azul doing, compiler optimizations, I said, let me do the final field optimization I want to do forever. And lo and behold, 3 different large 3-letter company, web server things, frameworks, Spring and some other names who I probably shouldn't mention still, but you've heard these names before, all cheated on reflection, via reflection, cheated on final fields. Okay. As a consequence, the JIT broke subtly and it took forever to debug what the hell was going on. I finally diagnosed it as you took the final off, you changed the field, you put the final on, the JIT didn't recognize this. Okay. So then I got all pissy about final fields, but separately in the H2O case, I made a new object that I knew was new. I set its fields in the constructor, including the final fields, which you had set in a constructor. And then I had an object that I ran away with. And then upon rare occasion, I was deserializing a cyclic structure for which I had to use unsafe to set final fields.
But that is interesting, right? That because that goes back to Aaron's actual question, or also Theodore, in terms of binary compatibility, right?
Yeah.
If the spec would suddenly claim final fields can be handled as constants and are actually final, like especially static final,
Yeah.
that would be interesting, because that would be a breaking change for a lot of stuff. I mean, especially setting final. There's even people setting those fields.
So there's a compiler optimization that is related to final fields, but handles this well. And I started down that path and never got it done. And that is optimizing slowly moving fields, where the rate of change of the field is low enough that I can pay for a JIT to optimize its new value before it changes again. So I have to JIT it as a constant. I have to get a payback for it being a constant until you change it, and then I have to re-JIT.
So you would do that with a write barrier or something?
So I have some sort of write barrier to detect
Right,
the
okay.
change. And in the case of a field which I expect to not ever change, the write barrier is actually super trivial.
Right.
You never execute the code that changes it. So I won't even JIT the code. I'll just bail out to the interpreter. And if you blow out and hit the interpreter, I got all the time in the world because you've never run this code before. So I assume it could be slow or whatever, you know, I don't care anymore. So at that point, you have to run around and tag all the JITted code that was depending on the constant and say, quit depending on that constant and go again. And the obvious constant you depend on is 0, because many Java fields are never changed from 0.
So the question becomes, how do you recognize fields as slowly changing?
Oh, you tag them as this is the last time I saw it changed by somebody, and then there's a 0, 1 many, and you give up after many. It's same as I did this for lots of other things.
So you're having a some annotation hidden somewhere that says,
Yeah.
this hasn't been changed for 10 milliseconds, so
Right.
maybe it's safe to assume it's constant.
Right. So you're on the right track. The profiling, the internal profiling, there's lots of stuff you profile because it's cheap in the interpreter per se. So the bit here is, I haven't seen this field changed as a static field. So there's only one instance of the global is the easier one, and we can handle instance objects in a second. You just annotate a bit byte, a long value of the millisecond since last update or whatever. And then if the updates, by the time the JITting comes around, he can go look at a field, look at the last update, the interpreter slapped down, ask also, was there JITted code changing this field? Okay, no JITted code changing the field has appeared. The last update the interpreter ever did to it was some time ago. I will flag this field as it's slow moving. And now I won't make any JITted code changing it. And if the interpreter changes that field and he sees, and this is a slow moving field, he has to stop and do the deop hack thing, right? So all I need is a hack in the interpreter on field updates that says it's a static global. I'm going to ask the question, is there JITted code? If so, exceptional, expensive happens. If not, I slap down the milliseconds of the current time millis of my last update and I carry on. The JITted guy, when he's JITting, he asks the question of this field. It's been slow and there's no one writing JITted code to modify it. I'll flag it as a, whatever, and I'll put that in my dependency list so the interpreter can smack me around if it does change, and onward we go. So does that make sense for static globals? The change for instance fields is extremely similar, except you unify across all the fields. And the goal is to say, this field in some instance anywhere has not been modified. Oh. And that is a common scenario where people have big objects, they keep adding biggerness to it. And the old field, no one ever wrote to, and it's always still 0. But they test the field for 0 and exceptional, they do something weird. Test always fails, the code's always 0. You can shortcut away.
So again, JITting is about avoiding work and making assumptions.
Yeah, right. So this is a classic, what I call a heroic assumption. I assume this field will not change in the future. It hasn't changed in the past. I assume it will change in the future. So in the land of hotspot, there were several of these, of which at some point, the more common ones had to get a heuristic, which looked at the rate of change. So there's it never changed it changed at least once, and I gave it up and I never optimized it again. And then there was it changed and it seems to be stable, so I want to JIT on it again, but then it changed again, and then there has to be a heuristic count which says, here's the apparent rate of change, and then you can make a decision, is it worth JITting with the optimization or not? Because you have to stabilize or you'll be paying the JIT cost without getting the win back. So there's a bunch of timing heuristic games going on there where you're basically doing, oh shit, it's politics season here and I already voted. Hang on. Hello.
Mobile.
Yeah, I said hello first.
So we can search for another
Take
topic.
me off your list and don't call me again.
We can also just listen in.
So he doesn't bother to mute it. So
No, 99% chance it's spam.
yeah.
In the last 3 days, I've gotten a bunch of them. And also I'm in the middle of doing this home ownership, home buy, right? So I get weird calls from the title company. I get them from the realtors on the other side, left and right. I get, home inspectors and all kind of people, county wants, whatever, fine. So I have to answer the phone now. If I don't know the number, I'll frequently let it roll over to voicemail and spam filter there. But right now, for the next month, I have to answer every phone call. And it's still 90% spam.
I've taken to answering some of the calls, even if I recognize it as a spam number, but I'll just put my phone on mute and let them go for like 10, 15 seconds. Hello, hello, hello.
Right.
Waste their time.
Right. Well, the usual one I get is a computer talks at me for a long time, and then it gets tired and confused and eventually gives up. I do that kind of thing too.
I got an email the other day for a voicemail somebody left in my office that I haven't been to for 2 years, or is it 3? I forget now. And there's a audio file attached to the email notice. You listen to it, and it's kind of the latter half of a political request for my vote kind of thing, right? And I'm like,
From 2 years ago.
delete. No, it's a recent message, but I haven't been there for 2 years. So anybody that's paying any attention knows that's not a good place to get a hold of me.
Yeah, right. Yes. What do you do?
Okay. So Dan, did you have the question?
Did I have to what?
I was going to say we did the same kind of static final change detection in OpenJ9, but we didn't bother to do the track the change rate, because we found that most of the use cases, it was either something where someone was doing deserialization and it happened frequently enough that triggering it once was sufficient to poison it forever or not. And I'm just curious, do you have examples of the cases where the rate of change was slow enough that it was worth rejitting in between that?
Oh, not for the final fields. This was in reference to any number of heroic optimizations.
Okay.
So class hierarchy analysis. Somebody was constantly loading and unloading classes, but in the particular use case or call site in question, they typically had one a live running class, but that class would change when they unloaded and reloaded. So while you loaded a class, there was a single caller, you wanted to inline and you got whatever the code of the moment was. They ran that for a while, and then somebody uploaded a new version and they were doing a versionitis rollover. And so the new hot code was this other one class, but now you had multiple subclasses. And so you wanted to like say, oh, I don't want to do this. I don't want to have a virtual call, but I have multiple subclasses. And then a short while later, the garbage collector kicked in and yanked your extra subclass away, and you're back to a single subclass, but it's a different one. And so there was a constant recompile churn going on. And then there was a heuristic hack to say, oh, there's a flow rate of these that I can deal with, and a flow rate, I'm just going to give up and do what you said, and said, it's a virtual call, no inlining, suck it up, buttercup. So
That's interesting. I don't know that we tracked that kind of a class hierarchy change. I know we tracked the unloading, but I don't know that we went back and recompiled code.
It had a hot path.
Yeah.
I'm trying to remember where I hit this, but I know I put a couple of those in. There was one there. There was one in instance of checks where the default one free subclass check was constantly failing. And there was some other way we jitted it after a while, and we wanted to keep flipping who the instance of check was targeting. Oh, Aaron must have dropped and he's come back. Fine. Yeah, it happened a couple times.
Sounds like JSP classes where people are constantly loading and unloading. But
Right, it was some variation of a web server, a hot code was getting loaded, unloaded. And you wanted to do some inlining at some key point that somebody complained about. Why is this code slow? Jeez, dude. Quit doing this crazy thing. It won't be slow. Fine. There definitely were a bunch of heuristics we had to put in that said quit compiling, because we would deopt and recompile essentially the same code, then fail again. That showed up in funny places.
How much of your checks or counters or optimizations do you think aid just a bad code practice? Because you just can't.
All of them. Write machine code in the first place, and you won't have this problem.
The machine code it's a different story, because in Java you can do so much more and just rely on the JIT, make it faster.
Right, and what we went after was what people complained about for, you know, what turns into benchmarks basically, but the benchmark wasn't necessarily a public benchmark, but you know, some big bank, not to mention Deutsche Bank or whatever, would come through and say, we're going to buy $100 million worth of Java servers this next year. But our beloved app of joy here, like the web-facing portal and whatever, sucks. So, you know, fix it. Well, sucks and fix it landed on my desk, right? So there you go.
So you would say I would just make the JIT do this thing because
Right.
because money, because of reasons.
Well, reasons. It was money. Of course it was money.
Of course.
Sun was paying salaries and they had to get money to pay them. So, you know, this is all engineering time. It takes money. And then there was like some bright soul came along and said, let me do NIO and I'll just put in these, you know, the JIT works so well, I'll just put in these two subclasses. And of course, if you had one, I just inline it, was all happy. As soon as you had two, you went to a vcall. And then they're like, we got direct byte buffers, we got native byte buffers, or we're native and heap or whatever. And we wanted them both inlined in many places. And so that was a long, you know, custom optimization where I said, well, I'll allow two subclasses. If you're this, inline over here. If you're that, inline over there. Else you're the third, go make a vcall and I don't care anymore. Right. And that was just for NIO.
So a JIT is a correction for a bad practices.
Yes. Well, there would be a way to write the code where you didn't depend on the JIT to clean up certain things. So some stuff, like you're not doing register allocation at Java level, fine. But a lot of the inlining things and where it's hot and where it's not could be corrected reasonably at the Java level, but they didn't want to do it that way. So you have to clone some amount of the hierarchy of your code. And when you hit the inner loop and the inner loop says, I'm going one of two different choices, you have to go up a layer and inline. Here's the heap version of this loop, and here's the direct, whatever, the native version of this loop. And maybe you go up several layers. And the Java guys, you know, didn't want to do that.
But
So,
I would disagree with the general claim. So JIT is not always.
well, that's what I'm saying. It's not.
For that code. What I really like about the JIT solution, not only for Java, but also .NET and anything other which is JITted, is you can write code that solves a lot of use cases, but because of the JIT, you will get a perfectly optimized piece of code for that specific use case your customer is using at that point in time.
So yeah, but
And it will change over time if they change use cases.
Really common that today that you write code, you want to apply to every possible case and every applicable case, and the code you write becomes so general that you cannot make the assumptions, and you just hand this to the JIT to make your assumptions.
Certainly,
to optimize the code.
that's that's the scenario I walked through, but along a general path. Like I come from the world where everyone wrote C code, where optimizations were very specific or they weren't or whatever, to, hey, I can clean up some of your cases that C can't. I can clean up some more. I can clean up some more. I am walking down this path where from energy and effort, I can clean up some cases that let you write more general purpose code and still get performance out, right? So there was a path that hadn't been there. I made the start of that path. We can go further down that path a long way. Now we've opened the door. We can see that this path leads to this vast jungle of, we can clean up everybody's crappy code, right?
Yeah,
And-
that's
and-
what.
But I
That's
think
what
there's
I said.
there's one more important bit, right? You're thinking about it from the point of the code being written by the user, the Java
Yeah.
developer.
Yeah.
But
Okay.
if you look at the JIT, you also get the intrinsics, which know exactly on what hardware platform you're running. They know hopefully in the future at some point that you're actually having a GPU they can utilize for vectorization and all that kind
Yeah,
of stuff.
but you write your code specifically for that platform, okay? And again, you write your code in such a general case so that you rely
But-
on the
But
JIT
it's
to
not,
choose.
it's not me as a Java developer doing that. The JVM is
Okay.
the JVM
Okay,
developer
yeah.
is helping me doing that because I
Yeah,
would
it's-
probably be able to do it.
Okay, but the assumption is assumption, and the Cliff's disk becoming larger and larger and larger with the documents. So do this, do that. So
So what happens is that the sweet spot where your code runs fast gets wider over time. But you can still write crappy code that you can imagine a scenario where it could run fast, but the JIT's not doing it now. And then you have to
Yeah.
decide, do I want to go
you
there or
basically
not?
you basically switch your case to just testing, performance testing. It does.
Well, there's plenty, right. And then there's plenty of people who then forgot the cost model, never learned the cost model, didn't understand it, don't know it. And they write crappy code because they just don't know.
So again, JIT hides bad practices.
Well, I
Well-
actually I have a pretty good example the other way around, where the JIT normally helps, but with Hazelcast, we had a customer calling me or calling us. So I had to fly on site, and they said every time we switch from the hash map to Hazelcast, our code is like a magnitude slower.
Because
Well, obviously, because the JIT compiler knew that the hash map is certainly not thread safe, and there is no side effects, right?
Mhm. So
Well, with Hazelcast, you certainly had, or you suddenly had network involved and all that kind of stuff. It was, and they had a double loop, like a two-step or even three-step loop. I don't remember. And they basically called the same value like a million times in a loop. I was like, and the JIT compiler just moved that ahead of all the loops before that, right?
Oh,
Every
yeah,
time they
yeah.
used the hash map,
Yeah,
like they
the
expected
JIT
it.
the JIT becomes this interface to a complexity, to an
So
explosion
that
of
proves
users.
your point. It's good for bad code.
Yeah, for
Part
both,
of your
yeah.
cost model expectation. Boy, Aaron just keeps dropping and coming back in. Yeah, and do you expect everyone to understand that cost model? And if you went back to the 60s and 70s, that same argument was made. Do you expect everyone to understand the cost model for assembly? And the answer, of course, is nowadays, it's obviously not, right? The compiler does a good enough job. There are times when you must do assembly because you get some semantics you can't do otherwise. There are times you must do assembly because you get some performance you can't get otherwise, but that's rare and far between. So the fact that we've moved past that for 99% of the people, I think is a good thing. So now the JIT comes along and he cleans up register allocation and obvious inlining patterns and some obvious range checks and shit. And he lets you move past that for the large set of people. But there are still more performance problems out there, and people, asymptotic big O notation still matters and all this kind of shit. And in your case, somebody says, I did some stupid thing inside of a hash code that I could move out manually. The JIT did it for me, so I didn't care. When I called Hazelcast instead of a hash map, the JIT couldn't move it out for me. And I didn't understand because I don't understand the cost model. So I kind of blew it. Where do you begin the education of
That
here's
was
how
a
this
weird,
thing works?
So
I
there
think
has
that
to
was the
be.
weirdest consulting. It was 2 days and I had the solution after 10 minutes, but you can't tell them that they're just stupid, right?
Right. They're paying your money, so they're not that stupid.
Well,
They have a different skill set than you. One of them is
Exactly.
they can make
So
money
I'm not-
doing whatever the hell they do.
I'm not generally against the JIT making the decisions, but there hasn't guarantee that we will always do the same thing and that will always optimize the code doing the same thing, and that loses some of the.
Well, you know, the JIT goes on statistics. And he says, in the past, you did this a whole lot. I'm going to assume in the future, you're going to keep doing this.
And even
And-
multiple levels with C1, C2, and the interpreter.
But this basically works for nearly always. When it fails, then the JIT clicks more stats and says, and now I see this other pattern. I need to go change what I'm doing. And so you get recompiles and the statistics, you need them to be sort of monotonically approaching some sort of fixed point where I'm done here.
So one JIT, by the way, that I haven't seen a lot of use yet in terms of benefit is the JIT that was integrated in Postgres 12 or 13, 12, I guess. So
I
far,
don't
all
have-
these cases, the JITting time is just not worth the extra benefit of the calculation speed.
I'm sure it improves their TCPH benchmark scores.
But so would you make the same claim for GCs? Like they're for bad code and you don't have to
No. The
GC is an
GCs
illusion. GC is an illusion that you get in
GC
infinite memory.
GC covers a couple of unrelated different sins and makes life better in different ways for certain things, categories of things. So it removes a whole class of bugs, right?
which
So-
which
Yeah,
solves
I
bad
agree.
code.
No, but it makes life a lot easier that you didn't have to think about it,
Yeah,
right?
yeah. That's,
So it got you time to market quicker. It got you running code quicker. You just assumed I don't have to track lifetime. You forgot about how to track lifetime. You never learned how to track lifetime. Life got better for you, except for the GC penalty.
so you avoid the decision and avoid it and avoid it and avoid it, and that's a pile of crap.
Right.
Yeah.
Well, there's a lot of bugs in lifetime management and C code that go away now. So I claim it's a reasonable choice there.
Yeah.
So in concurrent algorithm code, there are many cases where tracking lifetime, while technically feasible, is just way too expensive. And in that case, again, garbage collection is the answer, where you're just going to throw away, you're going to CAS a thing in, and you don't care win or lose, you're going to walk away. And Dudley put this in spades and JDK5, the concurrent collections, and the GC picks them up afterwards, and you just never implement that algorithm unless you had a GC.
So you're saying the difference is that forgetting to free an object is an actual bug, whereas the JIT is just about speed then. That's what you're saying is the difference.
The JIT is about getting performance.
Okay.
Which performance is a bug. Lack of performance can totally be a bug. If I'm asking for the weather report and you can give me the weather report tomorrow, that's not helpful. I want it today, right? Tell me tomorrow's report today, not tomorrow. So
Right.
It has to run fast, right? I'm doing avionics controls, I'm fly by wire, my car's fly by wire, fucking whatever. If you're not fast enough, that's wrong. Okay, so there's a performance thing. Then there's garbage collection removes a class of bugs, which the JIT does not per se remove a class of bugs.
Okay.
Agree,
Yeah, I see your
agree,
point. That makes sense.
Okay.
agree.
Then in the case of concurrent algorithms, garbage collection lowers the cost to track lifetime, lowers the cost of implementing the algorithm by some huge orders of magnitude. So again, it enables a class of algorithms that you wouldn't ever otherwise be able to enable. And I claim that's an interesting aspect already. Like maybe Rust would help you, but unless you really can track the lifetimes in a concurrent thing in Rust, which I know Rust doesn't do concurrency, it is also not helping you. Okay, so then there's, I think it's the big semantic changes on GC. GC brings its own performance bugs in, including the non-deterministic, semi-non-deterministic pause time issue, which can be dealt with by a complete change of GC algorithms and some careful management. That's the Azul model for GC.
So
You can-
lower
What are
time
you
to
asking again? That there's why GC?
I was just asking if that would go down the same rabbit hole, like, hey, it's just a nice to have and it solves like bad code. And
Yeah, the JIT is nice to have by factor of 10x, which is fast enough that a lot of people care.
So it definitely lowers time to market, so we can test new ideas.
Yeah.
I
So-
would actually claim the JIT compiler does the same thing because it solves a lot of optimization issues for you.
That's what I'm saying. Oh, I heard the JIT solves time to market because I didn't care. It ran fast enough. I walked away,
Exactly.
right?
Oh yeah.
And reflection does the same.
Reflection is
I'm-
implemented, so different reflection meanings. Yeah, I
I'm
know
still-
you're
I'm still
trolling. I'm trying to
against
get conversation going, which is fine.
Yeah. Yeah, I'm still against reflection.
So reflection as done by the Java VM breaks the semantics of the language. And I'm opposed to that variant. There's versions of reflection out there which do not break the semantics of the language. And I think that's a fine thing.
Yeah. Yeah.
So they're different things though.
Yeah, the Scala macros is classified as a compile time reflection.
Okay, but it's not breaking the semantics of the language.
Yeah.
You could totally imagine a Java version that didn't allow you to, for instance, break public, private visibility rules, not break final rules, things like that.
Yeah.
If I want to add if I want to set a field that's mutable, I can do that in normal code. I can do it in reflection. There's no change, no difference.
I would argue that the public-private thing is not the same as something like final.
Yeah.
Because public-private has never been a security feature. It's only been an organizational feature.
Yeah.
So I'm sorry. Outside of delusional thought by Bjorn Strustrup and the developers behind Java, public-private protected has never been considered a security feature.
Yeah. Okay. Fine. Right.
So reflection should be able to whack away at public, private, whatever. But if it says final, it's final.
Well, okay. So you're saying reflection should allow to read a private field that normal Java code doesn't have access to. We're arguing Java reflection at the moment.
So I think your English is wrong.
Ah,
So I'm gonna give you a syntax error on your English.
excellent.
It's not that the Java code doesn't have access to it. It's that the compiler tells you that based on the code you wrote, you have told yourself not to access that field. And therefore, the compiler is doing you the favor of reminding you that you told it to tell you not to access that field.
Interesting.
It's not a security feature.
Right.
It is your way of organizing yourself out of a mess. Because otherwise, if you have just one giant namespace with everything in it, autocomplete is going to be like, okay, which one of these 400 billion names do you want to fill in, right? So think of public-private protected as reduce the number of options I have for autocomplete, not as pretend security.
But then
if you want
again,
pretend security, go to the airport and take your clothes off, right? Like,
yeah.
Sorry, don't do that. You'll get arrested. But you know what I mean? Like,
Then again, if you fix something private or public, or you do it generally as up in front, why do you need reflection to mess with the visibility of the fields?
No, it's not why. Is what should I let my reflection do? And I heard Cameron say, well, I wanted private so I didn't shoot myself in the foot accidentally so easily. My reflection is allowed to read my private fields because I'm saying it's okay in this context to read the field and not in these other contexts because I'm just telling myself.
So you said it, I don't want it until I want it. So
right. So this is like security would be, I have oh, that's different. So, okay. So there's some I'm shipping a library that I don't want you to peek inside of, right? And
if you want to totally hide the implementation.
There are two things here, right? One of them is, I don't want you to peek inside so I can change the implementation without you accidentally depending on some stupid thing that's going to go away tomorrow, right? There's another version which says, hey, my library contains the secret key to my bank account and I don't want you peeking in my library so you can't get access to my bank account, right?
Okay.
And those are, one is security and one is not.
It's actually interesting because I've always wondered why TypeScript actually bothered to add the private, because it doesn't do anything. The code will after transpiling to JavaScript will look exactly the same. It doesn't matter if you mark the method or field final or public.
Exactly.
That's,
And
yeah,
C,
that's,
and C
that
is
makes
the
a lot
same,
of
C++
sense.
is the same way.
The public,
Yeah.
the private is an object-oriented organizational future, and if you transpile to JavaScript, everything
Well,
collapses.
Yeah,
you can,
in
you
C++.
can still totally, you can still totally do that in JavaScript. It's just on a method on the object, or well, on the whatever prototype, but it's a variable inside of the constructor function, and that way you can never actually access it from outside. So there is a possible way to transpile that. They just didn't bother to do it.
If you look at C++ generated code and change your publics to privates and privates to publics and everything in between, there's no difference in the machine code. The only difference is in the RTTI side info that it generates. So there's no, private is not a machine code concept. It's not an assembly code concept. It's purely organizational for source code.
Yeah. So if it's a private public object-oriented compile time concept, why do you need reflection to mess with it?
It doesn't mess with it. What do you mean?
You allow the
should you design a reflection that can mess with it?
yeah.
Or should you design a reflection that it cannot?
A reflection that changes code isn't reflection.
Yeah. So looking at a field contents is one thing. Changing code is, yeah, definitely not.
Yeah. 'Cause I
Adding
mean,
code.
from my own perspective, once code is running, you know, your type system is an immutable concept.
It's
I've-
yeah, it's a thing in the past. So once the type system is there to help you at compile time, to restrict, to organize you, to prescribe what the code should do and can and cannot do, and this thing should disappear, because if you want to RTTI to runtime type information, you're incurring more information that has to at runtime know about your code and do things about your code. That's why I argue you don't need reflection, because if you done your job prior to compiling your program, then the reflection.
No, you're missing the point. So first of all, like you guys were talking about earlier about like changing something from final to not final and then changing it back.
Yeah.
So changing it is not reflection. Right? Because when I look in the mirror, I'm like, I would really like to look like Brad Pitt, but there's nothing I can do to that mirror to make it happen. Right?
Okay.
So the concept, in fact, reflection comes from this concept called mirrors, which is someone's brilliant thing from 1963 that I don't remember about, but basically the idea is that you're just viewing information about your type system or your code.
So in other words, you allow your type system to participate in your runtime of your program. That's I see it.
You allow it to be visible. You allow the meta information to be
that's
visible.
better choose of words. Yeah.
Yeah.
So
changing fields then is something different, because it's no longer just looking at what you are yourself. It is.
So I wouldn't consider changing fields to be reflective. However, reflection gives you the straw through which you can peek and poke a field. So think of reflection as being the meta information that the field exists, and then the field itself has some, this is an object-oriented concept, obviously, but you could think of the field itself as having the ability to access the value held in it or modify the value held in.
Yeah. So I agree with all that, but I'd qualify things by saying that reflection ought not to be able to change the type of thing. So it can let you look at that final field and let you read it, but it's final, its type is not writable. So you shouldn't be able to write through it through reflection. Another widely abused things is the set accessible. It wasn't accessible. I mean, you can see that it's there, but you're not allowed to read or write to it. And telling me to make it readable and writable is breaking the type system again.
Exactly. So think of that field as being an object. So when you say, hey, field, change yourself to accessible, the field should say, no. What are you talking about? I don't do that. Right?
But wait,
and if it's a final
why
field,
on that one though? I thought earlier we were saying that it's not security. So why shouldn't I be able to make a field accessible?
Well, it's not just about security. It's about all those optimizations that Cliff talked about doing earlier, like you just
That's about
included
final,
all
though.
those.
Yep.
No, that's what I was talking about, Mark. I wasn't meaning public versus private. I meant, am I allowed to modify? I shouldn't
Okay,
be
the
able to.
final versus non-final makes perfect sense, but yeah, you need to be able to sneak around private sometimes.
So the JIT
Yeah, absolutely.
optimization is like totally orthogonal. I can make the JIT behave as you expect if you are editing a field that you've declared final, but you're busy editing it with reflection. I can still make the JIT go to the semantic meaning of the field's this value, it's that value, this value, it's that value.
Okay.
Right. That is sort of unrelated. The question is, for me, the question is, what should I do with reflection? What is the right behavior I want out of my reflection? I particularly don't like the notion of I'm changing final fields out of reflection. I think I'm with a lot of folks,
So-
Keith too, about,
So
that
what
changes the type.
what
Fuck, no,
what a
you can't do that.
reflection should do? What a reflection?
But what should reflection let me do?
a nice reflection should do?
It should let you see yourself in the mirror. That's the point. And yourself is your entire type system. So
So,
you should
okay,
be able
Cameron,
to see that
thinking
in the mirror.
Think it about this way. You're planning a trip. You're beforehand. You saw on map where you go, where you stop, where you switch buses, on where you go on the train, and then when you go, you doesn't look on the map. Or should you do this thing or this thing or this thing? So your plan is erased. So you are executing it. So why do you want to keep come back to details in your program to change it somehow if you plan it beforehand?
Because what you're talking about planning corresponds to compile time, right?
Yeah.
So I'm going to build a serialization library today, and it's going to be beautiful. It's going to handle everything. It's going to handle nested recursion of infinite complexity with
So
lambda
why do we
dynamic,
keep
make up words,
pulling
right?
the
Okay,
reflection card of the
because it's a
serialization?
great example. Because it
But
proves-
it's the only
So,
example.
I have my library.
I can give
put
you
it
another
on
one.
I put it
Okay.
on the interwebs. It's perfect. I'm never going to change this library ever. Okay. Now
Yeah.
tomorrow, you write your accounting application, right? So you've got accounts and you've got balances and invoices and purchase
Okay.
orders, right? And
You have a
wanna-
new
You
data.
want to serialize your purchase order, right? I'm sorry. So sorry, you write your accounting application. The next day, someone takes your accounting application and my serialization library and wants to serialize one of those pieces from your accounting library. So they didn't write the accounting library and they can't change it for whatever reason. They didn't write the serialization library and I made it read only because it's perfect, so they can't change it. And they're building piece number 3 that doesn't have the source code for either one of them. And they want to serialize your thing, right? So
Yeah.
like the point is compile time is, it's such a 1950s concept, right? Like we're at runtime and we had a link time, a link slash, load slash link slash verify time. And before that, longer before that, we had compile time. And this is both the beauty of reflection, but also kind of shows what's broken about Java serialization. For example, like Java serialization, because reflection doesn't work to a large extent, doesn't work in Java with some of the issues we've been talking about. You can't build serialization in Java unless you change the JVM to do so. So when they put serialization into Java, they butchered the beauty of the JVM to make it work. And don't take my opinion on this. Ask the guys who originally designed Java. Ask Brian Getz, who struggles with this every day. Like it's an abomination, and they're actually working on getting rid of it. But to get rid of it, they're going to have to fix reflection.
So, okay. 1 point against reflection again.
No,
No, I think
there's always good points against bad design.
Yeah.
Or yeah, of course, agree.
What was your example, Mark?
Oh, yeah, I use it to do size of on objects, right? I need to walk the object graph to figure out what's retained. So it's similar to serialization, but it's definitely not serialization. And there'll be other things like that too, right? It's kind of where like you want to extend the JVM's capabilities. So
I'm
but it-
not against the reflection per se. I'm against the reflection at runtime because I've written a plenty of libraries in Scala, for example, that the compiler will wrote your serialization of a new class of an object. You just have to handle it. It doesn't generate the code at runtime. That's what.
Yeah, we call that IIOP. Nicely done.
Okay, I don't know the acronym what it means.
Corba. Come on,
Oh, cool.
Cliff, smile.
Okay. So that's why I'm skeptical about function at runtime. At compile time, it's fine.
I've just seen too many use cases for what I would call eval. And then, reflection is just the eval spelled out the hard way, but it's still the same set of behaviors. So I would like reflection / eval to be available, but do only the things that the language allows you to do in the first place.
But eval goes against your structure of your program. Again, you structure your program beforehand and you want to eval to do anything in the world, and
The eval does anything that the structure allows it so far that's been presented. It lives within the constraints of what you already wrote. So, a question in the case of Java reflections, we kind of agree that the set the final and clear the final, it seems bad. So if I have a field which is listed as some sort of private, do I allow you to know that it exists? It's not accessible. Do I even talk about it? Right? I have some internal state, but all you can tell maybe is I have internal state. You don't know what it's called and where it is. Or do I say, and this field exists, but I don't let your reader write it? And then there comes a question of, of course, with Java's first, the next thing you do is you say, well, I'm going to be able to read it, and so you flipped a bit and say, I'm going to read it now. But that we argue is a bad Java version of reflection. So reflection says, here's the set of things that I expose outside of myself. That's what you can see. Or is reflection the set of things, if run within myself, do I show you everything there is? I have the same accessing capabilities as regular code on myself. I think that's reasonable. But if I'm outside and I have an object I'm handed a foo object and I start reflecting on it, I see foo's external interface. All the fields foo exports, all the methods it exports, his subtypes, not his subtypes, all his supertypes, but not his subtypes.
So reflection should see the internals of of some kind of boundary, or should see all of the things as a whole as a program and zoom in.
What the external interface. So I hand you a security object that's got my hidden inside it my bank account key because you're doing a web interface for doing purchasing.
And you said private for a good reason. And
I've said right. And now can I reflect on it and ask questions like, is there a field called crypto key? Is there a field called account balance? And I try to go find you, right? I'm hunting your thing. Enumerate all your fields. And here I'm in the zone of your reflection should give you what your externally visible API is for this object class, whatever.
So reflection should let you inspect it, but not change it.
Inspect it the way and change it the way any external thing is. If I have a publicly writable field, you can write to it. If I have a publicly writable field that I'm only expecting you to write it through some API, I wrote my object wrong. I should have made that field, internal and then have an API that says, and here's where you update the size field, right? So if I have a hash table and I want to tell you how many objects are in it, I can make the size call and get the count. But the implementation of the number of fields, number of things in the table is not necessarily exportable, or it should be exposed. Because I have a size field, which happens to be cached, but I only update it when you actually insert something that didn't collide with a prior object and blah, 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 that's complicated. I don't want that field to be writable by somebody else, but maybe it's readable.
But this is why operating system has processes, and this is why the hardware has rings, right?
Yeah.
And so, if you don't want it to be readable and writable, don't put it in the same process.
Yeah.
Because that's the language C. Right? Like if you're in my process space in C, I'll get whatever is there, right?
Yeah. The assumption is all boundaries are crossable once you're in the same process. Yeah.
I've got a
Mhm.
40 or 48-bit flat space. I will iterate through every possible address. I'll get it and I'll set it and I'll put both of those within a trap and within an
Yep.
exception
Yeah,
catch.
I think that throws the baby out with the bathwater though, Cameron. Um, you shouldn't sort of give up and say you're not allowed to have any protection between players inside the same address space.
Oh, but I believe you should. I mean, that's what I spent the last 6
You
years
just
doing.
have to define what
You
an
just-
address space is. Right, so an ecstasy address space is service, not process.
Okay.
Yeah, and
Well, specifically
But
container.
the protection you like between processes, why can't we have similar protections, small
right.
grain things within a process?
right.
Well, we do.
Right, the JVM clearly allows some of that and not others of that, and can we get finer grained yet? And I know ecstasy is all about that, and that's one of your big schmicks, which I heartily approve of. It's a cool thing.
Yeah, it'll be working soon.
Okay. I hope it's as soon as not in the same breath as like me and type systems. It'll be working soon.
So we've got container loading and unloading working, but we still have some memory leaks. That's pretty
Okay,
cool.
excellent. Yeah, progress.
But containers are one of those boundaries we're talking about
Right.
in terms of, and if you're Keith, if you're in one container, if you're in a parent container, you can do whatever you want with a child container because you created that universe. You think of a container as a universe, right? So your universe contains something, a universe you create. You can do whatever you want in that universe you created. But from the child container, if let's say that security key is somewhere in the parent container, that's what you don't want the child container to ever have access to. So even if it knows the source code that's running in the parent container, and even if it knows the all the interfaces and all the types and everything else, it cannot see that information at runtime from the parent container. So
Yeah.
that's the goal. So even malicious code can be safely hosted inside a container.
Yeah. The goal is my account's running as a parent container with my bank account, and my child is the web interface I'm exporting out to go touch screen with and poke at and whatever. And I type in broken URLs and whatever shitty thing I want, and you're not allowed to have that escape and get into the parent.
Right.
Yeah,
And if you want to be able to do an eval of code that you don't trust, you should be able to create a secure container and run your eval inside that and let it go to town.
He has all the permissions that were given to the secure container, which would be, can't look uphill.
Yeah, I think
Seems
something
like
similar was done for modules and the method handle lookup with the lookup object, where you can basically hand out a lookup object for your classes, for the entity manager, for example, in JPA, to figure out and instantiate your classes. But if it's in a different module, you have to hand it specifically, otherwise you wouldn't be able to access those classes.
So this is the module thing kicking in.
Yeah. That was one of the things that was specifically added for that. And it makes sense.
All right.
So the verdict is reflection is useful. Okay.
Yeah, I think it is.
And by the way, that's not to say that some of the things you can solve with reflection, you can't solve with compilation, because you can. You can take, and we do this all the time too. We take code that someone wrote, we analyze the code, and we produce new code around it, and then compile that. And that's the way it always used to work before you had reflection. Like that's how we would do. That's why I was joking about Corba and IIP. That's how we would generate the.
I can give a more realistic example of that. So
Sure.
I've done JavaScript web interface, forward mobile interface, and I'm using React Native, ReactX. MobX is the state management with the DOM updates. And what MobX does is it declares some set of fields are tied to the state of your DOM, your display. And if you change this field, I need to trigger a repaint of the screen. So I intercept all reads and writes of this field. So MobX reflects in JavaScript land, gets the names of all your fields, hooks them so that if you write to them, he detects the write And then he knows that this field is tied to updating on this part of the screen. That's the part of the shit you have to tell him. But he makes it much easier for you to write an application where you have some application state that makes sense to you, and you have some display state that makes sense, and there's a delta change that you want to do and not a full repaint. He tracks the deltas behind your back for you. But that's basically reflection, looking at all your fields and intercepting all reads and writes to also trigger paint displays with the updates. This is a common coding style in the mobile domain.
Obligatory statement that Smalltalk did it first in 1975.
Not saying, but yeah, sure.
Okay. Do we have another topic? So we beat reflection.
Well, we can be done and go get lunch and stuff.
Yeah, of course.
I have, you know, home things showing up this afternoon right after lunch anyhow. So
Lunch was so hours ago. I think I like Mark's plan better. Go to a bar.
hey, Chris was just at his own bar. He was out on his back porch drinking beer.
Yeah, I like that plan too.
Yeah. Yeah. I got the time zone change, but that might happen, you know. We're saving the big one for when we close on Sunnyvale, but we close on the old house. Oh,
Yes, celebrate.
yes, this 2.5, 3 months of transition and the giant budget woes that come with it will all go away. Be much happier. All right. Any last comments? Wrap it up.
Thank you.
Yep. Nice
Have a good
talking,
weekend,
folks.
everyone.
Till we meet again.
Next
All right,
time.
bye-bye.
Cheers.
All right,
Bye.
see you, folks.